Imagine boarding a plane that doesn't roar during takeoff. It doesn't release black smoke into the sky. It doesn't burn thousands of gallons of kerosene. It simply takes off, almost silently, powered only by electricity. The flight is smooth, the air is clean, and the cost? Just a few dollars of electricity. This isn't science fiction. The technology already exists. In 2025, electric planes are real. They are being built, tested, and in some cases, even flown with passengers. So why aren't we flying them everywhere? Why do commercial flights still rely entirely on fossil fuels? The answer lies in physics. Let's begin with the most basic problem: batteries. Jet fuel is incredibly energy dense. 1 kilogram of kerosene contains roughly 12,000 watt-hours of energy. A modern lithium-ion battery contains just around 250 watt-hours per kilogram. That means jet fuel provides almost 50 times more energy than the same weight of batteries. And the situation gets worse. Fuel burns off as a plane flies, reducing its weight and increasing efficiency. But batteries? They weigh the same at the beginning and end of the flight. So any electric plane must carry all of its weight the entire time. That alone makes long-range electric flights nearly impossible with today's technology. Take the aviation Alice, for example, one of the most promising electric aircraft on the market today. It can carry 9 passengers and 2 crew members. Its total range? Around 250 nautical miles. That's about 460 kilometers. Enough to fly from Los Angeles to San Diego and back, but not much more. And this range is possible only in ideal conditions: no headwinds, minimal load, and perfect battery performance. If any of that changes, the range drops. Another issue is charging. With an electric car, waiting an hour to charge is inconvenient, but not catastrophic. With planes, turnaround time matters. A commercial aircraft must be ready for the next flight within 30 to 60 minutes. Charging a plane's massive battery in that time would require extremely powerful infrastructure, far beyond what most airports can currently handle. And then there's certification. Any aircraft intended for commercial use must pass years of testing and review. Regulators have to be sure that the aircraft won't fail, even in the most extreme situations. And electric aircraft introduce completely new risks. For example, what happens if a lithium-ion battery catches fire mid-flight? That question still doesn't have a fully accepted answer in aviation safety circles. Despite all this, the electric aviation industry is making progress. In June 2025, Beta Technologies completed the first electric passenger flight to New York's JFK Airport. Their aircraft, Allier, flew 49 minutes and consumed just $8 worth of electricity. The aircraft can carry 4 passengers and has a range of about 250 miles. That makes it suitable for regional flights. Another company, Heart Aerospace from Sweden, is working on a hybrid electric aircraft called the ES-30. It will carry 30 passengers, fly around 200 kilometers on pure electric power, and up to 800 kilometers using a backup generator. That's not long haul, but it's more than enough for many short-haul routes. And then there's the aviation Alice. Sleek, fully electric, and built mostly from lightweight composite materials. As of 2025, it has over 600 pre-orders from airlines. But even this plane is still waiting for full certification. And until that happens, no passengers will fly on board. There's also a lot of excitement around eVTOLs, electric aircraft that can take off and land vertically like helicopters. These are designed not for long routes, but for dense urban areas. Think of a quiet, electric air taxi that lifts off from a rooftop and lands a few kilometers away, avoiding traffic. Companies like Joby Aviation, Archer, and Vertical Aerospace are racing to make that vision real. In Saudi Arabia and the United Arab Emirates, trials are already underway. But again, range is a limitation. Most eVTOL aircraft fly about 100 to 150 miles on a full charge. That makes them perfect for commuting or short-distance connections, but entirely unsuitable for traditional aviation use cases like intercity or international flights. To make electric aviation truly mainstream, we need a breakthrough in battery technology. New types of batteries like solid-state lithium-sulfur or metal air could offer significantly more energy per kilogram. But none of these are yet ready for mass production, let alone certified flight. Even if those challenges are overcome, the supporting infrastructure must be built. High-capacity charging stations must be installed at hundreds of airports. Technicians must be trained to handle high-voltage systems. Airlines must trust that the technology is safe, reliable, and cost-effective. And then there's the market reality. Building an electric plane is extremely expensive. Certifying it is slow. And airlines, already operating on thin margins, are hesitant to risk investing in something that may take a decade to pay off. Despite all this, the future of electric aviation isn't a fantasy. It's just a long way off. In the next few years, we will likely see electric aircraft used for short regional flights. Small air taxis will begin operating in megacities. Hybrid electric planes may start replacing turboprops on low-demand routes. And eventually, as battery technology improves and infrastructure grows, we might reach the point where electric aircraft can fly hundreds, maybe even thousands of kilometers. But for now, if you're planning a long-distance trip, you'll still be boarding a jet powered by fossil fuels. And that's not going to change tomorrow. The skies will go electric. Just not yet. Subscribe us for more videos.